Step into the world of Dmitri Ivanovich Mendeleev, the visionary hailed as the architect of elemental order. This slide marks the beginning of an exploration into the life and genius of a man who looked at the 19th century's chemical chaos and perceived a hidden rhythm. Spanning his life from 1834 to 1907, we delve into a legacy defined by more than just cataloging. Mendeleev famously left gaps in his periodic table, confidently predicting the existence of elements like gallium and germanium before they were even discovered. Join us as we examine the structural masterpiece that remains the definitive map of our material world, proving that nature is governed by a beautifully predictable logic. While often hailed as the father of the periodic table, Dmitri Mendeleev was a true polymath whose influence extended far beyond the laboratory. Driven by a relentless quest to bring order to chaos, his legacy is defined by three distinct roles. As the chemist, he discovered the periodic law, mapping the 63 known elements while predicting those yet to be found. As the industrialist, he revolutionized the Russian petroleum industry through advocacy for pipelines and economic reform. Finally, as the metrologist, he modernized the Russian Empire by introducing the metric system and redefining global standards of measurement. Together, these panels reveal a visionary who didn't just organize the elements, but modernized the foundations of Russian science and industry. Mendeleev's path to greatness was forged in Siberian tragedy and unyielding determination. Born in 1834 in Tobolsk, the youngest of over 14 children, his early life was marred by his father's blindness and the family's loss of income. By 1848, his father had died and the family glass factory had burned to the ground. Undeterred, his mother, Maria Dmitrievna, traveled 2,000 kilometers across the Ural Mountains to secure his future. Despite rejection from Moscow University, Dmitri was accepted at the St. Petersburg Pedagogical Institute in 1850. Even as his mother passed away and he battled tuberculosis, Mendeleev persevered, graduating with top honors, a testament to a brilliant mind shaped by immense hardship and a mother's final, desperate sacrifice. In the 1860s, chemistry was a science without a map. With 63 known elements but no agreed-upon weights or unified theories, the field was a fragmented collection of observations. This chaos became Mendeleev's challenge. While writing his 1868 textbook, The Principles of Chemistry, he sought a logical method to present these building blocks to his students. He realized that to advance, chemistry needed to transition from empirical guesswork to a rigorous, predictive discipline. His goal was clear: to find the underlying order hidden within these scattered cards of data. By organizing the known, he hoped to reveal the blueprint of the universe, turning a jumble of facts into a modern scientific foundation. Witness the moment discovery met obsession. On February 17, 1869, Mendeleev began a high-stakes game of chemical solitaire. He inscribed 63 element cards with their specific properties and spent 3 sleepless nights shuffling them into submission. By aligning increasing atomic weight with repeating chemical valencies, he sought the universe's hidden rhythm. Legend says the final breakthrough came not from a beaker, but a dream. Exhausted, he saw the table fall into place and woke to immediately transcribe his masterpiece. This wasn't just a list, it was a revelation. By mapping known elements and leaving intentional gaps for the undiscovered, Mendeleev proved that nature follows a predictable script, one he was finally able to read. Mendeleev wasn't just a clerk of chemistry, he was a scientist daring enough to break the rules to reveal a deeper truth. His core principle, that properties recur periodically with atomic weight, was so absolute that he was willing to challenge current facts to protect it. When data clashed with logic, he defied measurements, swapping the lighter iodine with the heavier tellurium to ensure chemical family alignment. But his true masterstroke was embracing the unknown. While his predecessors feared empty spaces, Mendeleev intentionally left gaps for elements nature had yet to reveal. He didn't just organize what was known, he mapped the undiscovered, trusting the rhythm of the universe over the flawed data of his day. Welcome to the moment where scientific theory crossed the threshold into prophecy. This slide highlights the stunning validation of Mendeleev's genius. His gaps were not absences, but placeholders for destiny. He spoke of EKA aluminum, EKA boron, and EKA silicon with such mathematical confidence that when gallium, scandium, and germanium were discovered years later, their properties matched his calculations almost perfectly. This unparalleled accuracy silenced the skeptics and transformed the periodic table from a simple classroom chart into an undeniable law of nature. By correctly predicting the unseen, Mendeleev proved that the universe doesn't just exist, it follows a beautifully rigid logic that he was the first to truly decode. Mendeleev wasn't just a man of elements, he was the industrial engine of the Russian Empire. This slide explores how he revolutionized a failing oil industry previously dominated by foreign imports and wasteful sludge. By applying scientific rigor to commerce, Mendeleev championed the world's first oil tankers and advanced pipelines, drastically cutting transport costs. He strategically moved refineries to the interior and fought to abolish restrictive lease systems, fostering private innovation alongside the Nobel brothers. The result was a dramatic economic pivot. By 1900, Russia produced half the world's crude oil. Through zero-waste refineries and scientific management, Mendeleev proved that the laws of nature could be harnessed to fuel a global superpower. In his final act, Mendeleev turned his obsession with order toward the very bedrock of science, measurement. As director of weights and measures from 1893 to 1907, he understood that a modern empire could only thrive on flawless, unified standards. He became the driving force behind the metric system in Russia, ensuring its introduction by 1899. His quest for absolute precision birthed the differential barometer and pioneering weighing methods, while his definition of the absolute boiling point reshaped thermodynamics. To Mendeleev, exactness was more than a metric, it was a moral imperative. By standardizing the physical world, he provided the language of truth required for science and industry to finally speak with one voice. Mendeleev's genius was never confined to a single chart. This slide reveals a polymathic mind without borders, showcasing how his intellect shaped every corner of Russian life. In the military, he engineered pyrocolloidion, a superior smokeless gunpowder. In the skies, he performed a daring solo balloon ascent to observe an eclipse, teaching himself to land the craft mid-flight without prior experience. On the ground, his agricultural experiments revolutionized crop yields, while his economic treaties, like the explicit tariff, built the framework for a self-sufficient Russia. Whether navigating the atmosphere or the complexities of national trade, Mendeleev proved that a scientific mind sees no limits, only opportunities to bring order, progress, and power to the world around him. Beyond the formulas and fame, Mendeleev was a man of fierce, often defiant conviction. This slide explores the unconventional, uncompromising, and unstoppable character that defined his life outside the laboratory. We see the rebel professor, who resigned his prestigious university post in solidarity with protesting students. We also glimpse his scandalous romance with Anna Popova, a union so defiant of church law that it required a bribed priest to navigate a charge of bigamy. Even his physical presence was a rebellion. His iconic, unkempt hair and beard were cut only once a year, a personal standard he refused to break, even for the Tsar. Mendeleev reminds us that true genius is often as volatile and untamable as the elements themselves. Even the most orderly lives can be disrupted by the volatile chemistry of human ego. This slide examines what many consider the greatest oversight in Nobel history. Despite mapping the universe's building blocks, Dmitri Mendeleev never received the Nobel Prize. Though nominated 3 times and coming within a single vote of victory in 1906, he was thwarted by a professional grudge. Svante Arrhenius, a previous laureate, weaponized his influence within the Royal Swedish Academy to block Mendeleev in retaliation for criticisms of his ionic dissociation theory. It is a sobering reminder that while the elements follow a predictable logic, the committees that judge them are often governed by petty, unpredictable politics. Mendeleev died in 1907, his genius validated by science but denied by the Academy. As our journey nears its end, we see that Mendeleev's legacy is far more than a classroom chart. It is a universal framework where order is meticulously extracted from chaos. His life was anchored by a single, unwavering philosophy: the universe is governed by discoverable, measurable laws. This final pyramid illustrates the perfect synthesis of his genius, where the bedrock of precise measurement supported vast industrial applications, eventually rising to the peak of theoretical order. Mendeleev challenged us to find the general reign of order in nature. From a childhood of Siberian hardship to becoming the architect of our material reality, he proved that through science, we can decode the very logic of existence. The map is complete, the chaos has been conquered. Dmitri Mendeleev's influence did not end with his death, it became etched into the fabric of the universe. This final slide commemorates a legacy that transcends time. In 1907, during his state funeral, Thousands of students honored him by carrying his periodic table through the streets like a sacred banner, a testament to the professor who changed their world. Decades later, in 1955, he received the ultimate scientific honor when researchers at UC Berkeley named element 101 Mendeleevium. By embedding his name into the very system he architected, humanity ensured his genius would be eternal. Mendeleev provided the definitive map of our material world, leaving behind a tool that remains our most powerful guide to understanding the cosmos.